Hi everyone. Today I want to talk to you about direct and partial variation. So this is into chapter 5 out of your textbook, Modeling with Graphs. Specifically, we just want to figure out what the difference is between direct and partial variation when we're looking at linear graphs. So we're going to start today with a couple of situations. The first situation is going to be about a direct variation. So a direct variation is when one variable varies directly with the other. And a good example of this is this situation. So Nellie eats 4 cups of dog food every day. We want to complete the table of values. So let's begin there. So at 0 days, how much dog food would Nellie have eaten? Well, none. We're at day 0. Assume this is what you don't even have Nellie the dog yet. So no cups of dog food would be eaten that day. After the first day, Nellie would have eaten 4 cups of dog food. And then by the second day, Nellie would have eaten 8 cups of dog food. By the third day, Nellie would have eaten 12 cups of dog food. And then by the last day, day 4, Nellie would have eaten 16 cups of dog food. By then, you might be running low on dog food. Okay, so now we want to write an equation that represents this situation. When you're trying to figure out your variables that you want to write with the equation, go back to your table of values if you have one, and take a look at the headings in your columns. So we have number of days and the total cups of dog food. So the total cups of dog food, let's let that be T. T equals total cups of dog food. And then our other column, our first column, number of days, that's our independent variable. So I'm going to let that be n equal number of days. Okay. And once you have your 2 variables stated, we can come up with our equation. So the total number of cups of dog food eaten would be 4 cups per day, so T equals 4n. There we go. All right, from here, we can graph the relationship. So I'm going to go back to my table of values. I have all these points in there, so I'm going to plot them. So 0, 0 is right there, 1 and 4, 2 and 8, 3 and 12, 4 and 16, and so on. Okay. And then I'm going to put in my line that shows what's happening here. Now, because this is a direct variation or partial variation, these are not like scatter plots. Scatter plots, you draw your line of best fit and you go through as many points as possible, leaving some points on either side. This will not happen with direct and partial variation. You will always get a line that goes directly through all your points, okay? So please do not think that it's okay if you have a point that's outside your pattern. If you do, you need to go back to your table of values because you've done something wrong. You will always get a nice straight line through all your points. Okay, also notice number of days. So number of days, which was, first, just move that back. Number of days, which was first in your table of values. So that's right there. Notice that that went along the bottom. Okay, so that's always going to be your independent variable, where total cups of dog food is your dependent variable. It's going to go along your y-axis. So just be very careful on that. Remember, whatever comes first goes along the bottom because it's your independent variable. All right, so now we have a question, and it says, how many cups will Nellie have eaten after 1 year? So obviously using our graph to solve this is not going to be a good idea. Our graph only goes up to day 5, and we need to talk about day 365 since it's 1 year. And so I'm going to use my equation. So my equation is T equals 4n. Well, I know what N is now. N is at 365. And if I take 4 and multiply it by 365, I end up 1,460. So Nellie will have eaten 1,460 cups of dog food. Okay, so important, of course, to answer the question fully. All right, so what makes this a direct variation? So that's what I really want to talk to you about. Now, the reason why this is a direct variation is because one variable varies directly with the other. And how we can tell that is right here in our table of values. There is no initial fee, no extra cups of dog food that Nellie starts out with. So what that means is we have something that starts at 0, 0. If you have a table of values that starts at 0, 0, or you have a graph and you can see that it starts at 0, 0, then you know it's a direct variation. The way that we can tell with our equation is that it only has the one number in front of the variable. Okay, it doesn't have anything else added or subtracted to that equation. And since it only has the one number in front of the variable, it is a direct variation. So from the table of values, we can see it's 0, 0. From the graph, we can see that it starts at 0, 0. And from our equation, we can see it just has the one number. And those are the three ways to tell that this is a direct variation. Let me show you what a partial variation looks like, and then that may give you a better idea of how they differ. So here's our second situation. We have a taxi that charges 50 cents per kilometer plus a flat fee of $3. Complete the table of values. All right, so that flat fee, that's very important. That means the moment you get into the taxi, they're going to charge you $3, no matter what. He hasn't even, or they haven't even driven anywhere yet, and they're already, you owe them $3 for just getting into the taxi. From there, they're going to charge you 50 cents for every kilometer that they take you somewhere. So in our table of values, we can see now, even if you've gone 0 kilometers, you're going to be charged $3. That's for just getting in. And then for every kilometer after that, your price goes up by another 50 cents. So at 1 kilometer, you now owe $3.50. At 2 kilometers, you're up to $4. At 3 kilometers, you're at $4.50. And at 4 kilometers, you're now up to $5. So that one-time fee changes things, because then you don't start at 0, you start at $3, and you're working your way up by 50 cents for every kilometer after that. So let's talk about an equation then for this. An equation, again, I need to state my variables, so I'm going to start with T is total cost. I get that from looking at my second column in my table of values, and I'm going to let's say N equal number of kilometers. All right, so this will now allow me to write my equation. So let's do that. My equation then would be my total cost. My total cost is 50 cents. So notice that's where my 50 cents is going per kilometer, plus I have that $3 charge from the moment I set foot into that taxi. So total cost is 0.50 N plus 3. All right, let's graph this situation. So now we're going to get into some graphing. So notice now, again, number of kilometers is along the bottom because it's our independent variable. Total cost is along the y-axis because it's our dependent variable. The cost depends on how many kilometers we go. And I can start plotting points. So at 0 kilometers, I am already being charged $3. So right there, I'm starting at 3. And then I'm going to go up by 50 cents. So at 1, I'm at 50. Oops. That's not working out so well. Sec. Let me try that again. So at 0. I'm at 3 at 1. I'm at 350. Oh, I'm way off. Sorry. I have a touch screen here and it's just not helping me. It's not precise. Okay, so at 1, 150, it's in there. Then 4, and then 450, and then 5. Okay. Mine's a little bit messy, but I'm sure yours is looking great. And then from there we go. We have this straight line that'll cut through it. All right. Now, last question for this. How far could you travel if you had $10? So we got to think about this $10 and what it represents. Does it represent our total cost, or does it represent the number of kilometers driven? And since it's money, we can see right away that that's equal to our total cost. So I'm going to go back to my equation, and where there's total cost, I'm going to put it in 10, and that leaves me with 0.50n plus 3. And now I'm going to have to use my skills on solving equations. Let's subtract 3 from each side. Gives me 7 equals 0.50n. And then I'm going to divide each side by 0.50 and 0.50. And those will cancel, leaving me with n, and that's 14. So how far could you travel if you had $10? I could travel 14 kilometers. All right, what makes this a partial variation? So that's the important part. Let's talk about partial variation for just a little bit here. So right here, we can tell from our table of values that we are not going through 0, 0. We are going through 0, 3. So we are not going through the origin. So that's what makes us partial. I can see it right here on my graph. I did not go through 0, 0. I went through 0, 3. So that makes it partial. And down here, having this plus 3 in my equation. So now we have two numbers, right? We have not only the number in front of our variable, but we also have this other number that's being added or subtracted. Those three things are what make this a partial variation. Okay, so let's organize this a little bit. So a direct variation goes through 0, 0. Okay? Whereas a partial variation does not go through 0, 0. Okay, and that's really kind of the basics between direct and partial variation. They are both straight lines. They both go through every single point. It's just that direct variation, because it varies directly, it will always go through 0, 0. But a partial variation, still a line, just does not go through 0, 0. Your equations will look like this: y equals mx, where this m just represents some kind of number. And this equation for partial, mx plus b, again, m is some kind of number, but b is also a number. So we have kind of two things going on there with our partial variation. And then our graphs, let me just draw a couple of grids. So your graphs are, if it is direct, it will go through 0, 0. It doesn't have to be positive, though. It could also be negative. So I'm going to draw a second one here. It could also be negative. And same thing with partial. It does not go through 0, 0. So as long as I draw some sort of straight line and it does not go through 0, 0, then it is a partial variation. So hopefully that can kind of organize your thoughts around direct variation and partial variation. All right. Let's just take a look at a couple of situations and see if we can decide if they are direct or partial. So we're going to come up with equations. So important for us to get really good at coming up with equations. And then we just want to state whether or not it's direct or partial. So we're going to take a look at two different situations. So for the first one, for a wedding reception, a hall charges $500 plus $25 per person attending. So let's let T be the total cost then for this wedding reception. And let's let N equal number of people that actually attend. All right, so our equation then would be our total cost is going to be that $25 for every person that attends, plus the $500 to just even rent the hall. So that's a one-time charge. It doesn't get charged over and over again, just one time, $500. Okay, so we can see from here, not only are we having a cost per person, but on top of that, we have that one-time initial fee, that charge. And so this situation then is, if you said partial, you're right. It is a partial variation. Okay, let's take a look at the second one. The second example says every 12-pack of Pepsi costs $3.99. So we, again, can talk about T as a total cost. And we can let's say P equal a 12-pack of Pepsi. Okay, so I want you to be very careful on this one because a 12-pack of Pepsi is the item that you're buying. That 12 does not get thrown into our equation anywhere. It's not a one-time fee. You do not have to pay like $12 extra every time you buy a case of Pepsi. So it's a 12-pack of Pepsi. That is just the item that we're talking about. What we are talking about, though, is our total cost is going to be $3.99 for every 12-pack of Pepsi. So there's our equation. T equals 3.99p. There is no charge. You should not be charged anything extra, one-time fee to buy Pepsi. And so because we only have that one number in our equation, we can say it is a direct variation, just like that. Okay, a little bit of practice for tonight. Over the next couple of days, please take a look. We're going to have an assignment coming up. If you have any questions, make sure you reach out to me, and I will be certainly glad to help you.